resources. So this is called the resource. You must use some kind of technique called resource smoothing, or we call leveling. So this involves attempting to even out varying demands on resources by using slack. So you have studied the network diagram. The free time you have is called the slack. So you make use of the slack by delaying the non-critical activities to manage the resource utilization when resources are adequate over the life of the project. So now the time is you don't have, let's say, enough time. So you go and delay the use of the resources based on the time that you have. So the second type is resource constraint scheduling. So this is the duration of a project may be increased by delaying the late start of some of its activities if resources are not adequate to meet a peak demand. So you need certain number of resources, but you don't have enough. Then in that case, you also delay certain starting of certain activities so that you wait until that resources are available, then only you start that particular activity. So this is called the resource constraint problem. So the first one is time constraint, and also one type is called time constraint. Second type is resource constraint. So what are the types of project constraints that you're going to encounter? So the first type is called technical or logic constraints. So these are constraints related to the network sequence in which project activities must occur. So that means you cannot start the second activity until the first activity is completed. So for example, I think all the teams from group 3, you are going to start the HOTS assessment survey, or gather the HOTS assessment score from the respondents, but you are waiting for my student to finish the system first. So you cannot start to collect the data of the HOTS assessment data until my student completed, and you can use the system to collect data. So this is called the logic constraint or technical constraint. So next is the physical constraints. So these are activities that cannot occur in parallel or are affected by contractual or environmental conditions, physical. So if, for example, if in my class, let's say if we have a physical lectures on, and I'm using the DK2. So DK2 can accommodate 200 students, okay, all the seats. If now with COVID-19, let's say you allow even physical, you have to social distancing. You have to have one seat and then one empty seat and then another seat, another person sitting. So you have to, in between got an empty seat. So that will reduce the number of seats that can cater for the student if I have it physically. So in that case, let's say the room is 240, it becomes reduced to 200. So it becomes 100 only. So even if 200, if can everyone sit next to each other, the room also cannot cater for my needs because my class got 240 students. So this is known as physical constraints. So we sum more with this COVID-19. So if 200 seats become 100 seats, allow students to sit. And also, again, it's also physical constraint, even worse, cannot cater for 240 students. So physically, that's called physical constraint. So it's constrained by the environmental conditions, the environment that around you. So that's called physical constraints. So next is the resource constraints. So this is the absence, shortage, or unique interrelationship and interaction characteristics of resources that require a particular sequencing of project activities. That means not enough materials. It can be not enough of a human or the staff, the skilled people, experienced people to help you, or equipment that you need over a certain period of time of your project. So at a certain time, you need a lot of resources, but you don't have enough. Okay, maybe you have partially 50%. Then how you overcome this resource constraint? So now if we first take one illustration here, look at the constraint examples. The first example diagram here shows the technical constraints. So for example, the first one, the part A1 is showing, let's say you want to frame, build the frame of a house. So you start and then you pour the cement, pour for the foundation, pour cement for build the foundation, and then put up the frame, and then you put the roof. So this is the outline, the skeleton of the house, and then you end just putting the frame of the house. So for programming, you write a program, then you have a start, you design your program, then you do the coding, you do the testing, and then you end. So you see, this is technical constraint. So it's just like you cannot start coding until you have the design of your system. You cannot do the testing until you completed or you have some part of your program codes done. Then only can conduct testing. So this one, you must follow the sequence. So it's known as technical constraints. So the second one, resource constraints. For example, this one, you want to organize a wedding reception. You have the planning. Then if you look at the part C here, you start with planning of the wedding reception. Then you hire a band, and then you decorate the hall. After that, you also purchase or order the refreshment, and then you have the reception. So this one is sequence. You can see this is in sequential form. So that means you only need one person to do the hiring of band. Then the person go and decorate the hall, and the person go and conduct the order, the purchase, the refreshment, and then you can have the reception organized help on that day. So, but if you have you want to do it in parallel, one person cannot do it. So in the part B, you can see you will need more than one person, because if the activities, purchase, refreshment, decorate hall, the hire band, they are doing it at the same time. So one person cannot handle all the three at the same time. You need probably at least three people. If one person do one thing at a time, then you need three people to help you to plan this wedding reception. So in this case, if you have only one staff, then you have resource constraint, not enough of manpower. What kind of resource constraint you can face? So just now I mentioned people, that means human. Okay, the manpower you need, they can be the skilled people or not so skillful people. Materials that you need for your project or for your activities, and then equipment usually refer to machinery. Okay, larger things. So material, like for example, if in the building, let's say construction, you need the cement, you need the doors, you need glasses, all these things to build the materials for the house. Equipment, you need bulldozer, or you need backhoes and so on. Equipment that is required. Okay, so people, of course, the staff can go and do the work. If not, nothing can be done. So human is the most important. Okay, the manpower is the most important. So next, how we handle this? Okay, before that, classification of a scheduling problem. So using a priority matrix will help determine if the project is time or resource constraint. So just now I already mentioned there are two types of constraint. First one is called time constraint. Second one is known as resource constraint. So how you overcome time constraint and resource constraint? So for time constraint project must be completed by an imposed date. So remember you have learned the priority matrix. So you have defined if time is constrained, remember time is fixed, is constraint. So if remember you have a constraint and you have the enhance and then you have accept. So from there, you know, if you put time is constraint, that means this is time constraint project. So in this case, time is fixed. So if your project say you must deliver the project by 15 January 2021, that is time constraint. So you must make sure that you complete the project, deliver your outcome by that date. So this is known as time constraint project. So if in your priority matrix, your time is constrained, that is called a time constraint project. So in this case, if time is constrained, time is fixed, resources are flexible. That means you got a lot of resources, you got enough manpower, a lot of materials, equipment can help you to complete the project, although time is fixed. So in this case, additional resources are required to ensure project meets the schedule. So in this case, you make use of the whatever resources you have to overcome the time constraint problem, and you're still able to finish on time. The second type, which is resource constraint. So this is one in which the level of resources available cannot be exceeded. That means if you have, let's say in your team, you have only 10 people, you can only have 10 people, cannot exceed 10 people. The resources are fixed. See, the number of resources, whatever you have, they are fixed. Time is flexible. That means you can adjust your time. You can extend or you can shorten it. So inadequate resources will delay the project. So if in this case, because it's resource constraint, so if you don't have enough manpower or enough material or equipment, it will cause the project to delay in this case. Then you must learn how to overcome the resource constraint problem. So next, we look at resource allocation methods. So based on just later assumption here, to understand it easier, so they make some assumptions here. Limiting assumptions. So you cannot split. Okay, the splitting of activities is not allowed. That means if let's say one activity A is started, you cannot say activity A stop and then you start B and then come back start A. No, you cannot split the activity. You must once started, you must continue until the activity finished. So once activity is started, it is carry on until completion. Okay, so in this assumption here, this Example here say one activity started must carry on until completion. You cannot stop halfway and then you resume later after go and do other activity and come back again. No. So in this example, one started until it finished. So level of resources used for an activity cannot be changed. That means if you let's say I need 5 people throughout this period, you need 5 people. You cannot say 5 people become 3 people, 5 people become 10 people. Cannot. Okay. So this is the example here, the assumption for this example. Another one is about risk assumptions. Activities with the most slack pose the least risk. So of course, you understand what is slack. So let's say if you have slack of, let's say, 30 days, you compare with slack with 10 days. Of course, the slack with 30 days, it will not give you risk because it got a lot of time for you to delay. So reduction of activity does not increase the risk. So if you reduce this activity, the slack, you're using this slack, still does not increase the risk of the project being delayed. So the nature of an activity, whether this activity is easy activity or it is a complicated activity, it does not increase the risk. So this is another issue that mentioned here. So another assumption here. Just a minute, come disappear already. Alamak. Just a minute, I have my slide disappeared. Can you still see the slide? Yes.
Yes.
Can you still see because just now for my screen disappeared. Okay, thank you. Yeah, because my one disappeared. Okay, so that means the activity is you don't care whether it's complicated or easy. So that is the assumption here. So next we look at how we overcome these time constraint projects. So just already mentioned, so if time constraint projects must be completed by an imposed date. So if you fix the date, so I must finish by 15 January 2021, that is the imposed date. You have to finish on the date. Cannot be earlier, cannot be later. It's time constraint. So you require use of leveling techniques that focus on balancing or smoothing resource demands. That means you try to smooth the resources that you have. So using this method called leveling. So use positive slack, delaying non-critical activities. So you make use of the slack you have in your network diagram. You delay the not so critical activities to manage the resource utilization over the duration of the project. So by doing that, so what do you get? The peak resource demands are reduced. Whatever, let's say you need 10 resources, you will reduce, let's say come down to maybe 8. So resources over the life of the project are reduced. You see, because you reduce the maximum of from 10 become 8, then you don't need so many type of resources at the maximum that you cannot have. Fluctuation in resource demand is minimized. That means the up and down. Sometimes I need 3, sometimes I need 5, sometimes I need 8. So the up and down of this fluctuation of the demand of resources you require is reduced. So let's see an example here. So for example, this is the botanical garden project. So this is, you can see the BH here is stand for backhoes. So here you want to go and have built this botanical garden. So you start with design, and then you have the layout as clarified, and then you build the walkways, and then you go and install the lightings, and you do irrigation, you do the fencing and walls, and then you do the planting. And then you can see this the flow, the sequence of the activities from design, and then go to the next and so on. Okay, and you can see this line here, it shows the slack. Okay, this line here shows it means the slack. And this 2BH means this is the backhoes you require for that particular activities. So in this case here, layout is clarified, you need 2 backhoes, and then walkways you need 1. And at the same time, this is parallel with the irrigation, fence and wall, you need 1 and then 2 here. And followed by the lighting, you need 1 backhoes. And lastly, the planting, you need 3 backhoes. So do you know what is the backhoes look like? Okay, if you do not know, this is how a backhose looks like. So this is a backhose here. Okay, this part. Okay, this one is the backhose. Understand? So for the botanical garden, you need this equipment here, or this machinery. Okay, right. So next, okay, first what you do is you load. Okay, you load this requirement here, the resources you need. So this one you just put here, you don't need any backhoes, so you leave it. Next, you see from this time unit go down, you need 2 BH. The number of backhoes required. So from this unit number 1, the period 1 to 2, 2 to about 4. Then you need 2 BH here. Just look here. And then next one, you got 3 parallel activities, walkways, irrigation, fence and walls. You have 1 unit, 1 unit, and 2 units. So total is 4 units here. Next, followed by 1 BH from period 10 until period 16. And lastly, 3 BH from 16 until 24. So you can see there's a fluctuation. So this one is minimum 2, then go up to 4, and then go down to 1, and then go down to 3. So you can see up, down, up, down. Okay, so that's called the fluctuation of resources you require. So now how you do leveling? Now you look at this diagram here, this network diagram, you can see which are the activities that you can have slack. So this is the line here, it shows the slack here. You can see irrigation, you can have a slack here of from unit period number 10 until 16. So you have total of 6 units, right? 6 units of slack here. And fence and walls also you have the slack. So same number of slack you can have 6. Okay, let's say assuming it's 6 days. Okay, so now how do you do the leveling? So which one will you choose to delay the use of this? Because let's say assuming here in this case, maximum you have is maximum unit is 4 BH. So let's say if you have only 3 BH, you can use at one time. So which activity you can delay? You can postpone, delay the starting of this. You can have 2 only. One is the irrigation. The other one is the fence and walls. You can delay to starting. Instead of from the unit 4, you can start from unit 10 here. So which one will you choose to achieve this leveling purpose of these resources? Which one do you think you will choose? Any idea? Irrigation, fence and wall. Which one?
Irrigation.
Irrigation.
If you bring irrigation here, so this one remaining 2 plus 1 is 3. So this is 1, 1 here, right? Isn't it? So if you bring this one to start from here, right? So this part become you need only 3 units, 2 units, 3 units, and then 2 units, 3 units. Am I right?
Yes, I think so.
So you will see that you will have 2 units and then 3 units, and then you understand if this one bring delay this one irrigation, so that means you start from here onwards. So the resources you require beginning is 2 units, and then followed by 3 units, and then 2 units, 3 units. So it's 2, 3, 2, 3, right? So can you see there's a fluctuation? 2, 3, 2, 3. 2 up, down. See or not?
Oh.
Okay. So the purpose of level means I don't want a lot of up, down like that. So which one should you choose now?
Fence and wall.
Yes, that's right. So if fence and wall, the fence and wall, you delay this from instead of the starting from the 4th unit, you postpone to this 10 unit, delay to 10. So this become beginning unit 2 BH, then you need walkway and irrigation 1, 1 each, that means 2. So it's 2, 2, then 3, 3. You see or not? So that means it's level and then it's 2, 2, then up 3, 3. So it's only 1 down, up only. You understand? Okay, now you can see here. You see or not? So 2, 1, 1, and then 3, 3. So it will be only 1 down and then 1 level up. You reduce the fluctuation. So this one is down, up, and then down. The original one is 2, 4, 1, 3. So you do the leveling, you delay the with the slack activity you have, then you just become 2, 2, 3, 3. So that's called the leveling technique. So you look at your network diagram and see which is the best to delay the activity so that you reduce the fluctuation. So by doing that, also you don't need the maximum of 4 units, which you don't have. Maximum you can have is 3 units of BH. So you solve the problem of this a problem of resources that you don't have the maximum resources you can have, and you reduce it and also reduce the fluctuation. Okay, so now you can see originally this is the shape here, and it become this shape here. You don't need so many units. Okay, so you pick resource demands are reduced, fluctuation in resource demand is minimized. Okay, so that's called leveling technique. So here the resource allocation method. So in this way, you see the resource demand leveling technique for time constraint project. What are the advantages? So now we illustrate to you, explain to you. Peak resource demands are reduced. Resource over the life of the project are reduced. Fluctuation in resource demand is reduced, is minimized. So what about these advantages? Because you are making use of the slack, so become a loss of flexibility that occurs from reducing slack. See, you are using a lot of the slack. So just now was starting from 4, you delay it and it become no more slack for that particular activity. So reducing the slack you have. And next, if you're reducing the slack, increases in the criticality of all the activities. So whatever of activity affected, it becomes that in the end, it will resulting in some of activities from not critical become now critical. So you increase the criticality of some of these activities if you delay some of these activities to have the leveling technique. So next we come to resource constraint. So resources are limited in quantity or availability. So activities are scheduled using heuristics. So the term heuristics means rules of thumb that focus on, so what is this rules of thumb? So the first rule says you choose the activity that have the minimum slack. The second rule says you choose the smallest or the least duration. The third rule says the lowest activity identification number. So why you need 3 rules here? So minimum slack, because many activities can have minimum slack. Let's say this activity A got 2 units of slack. Activity number B is also 2 units of slack. So there's a tie. So because if they have same minimum slack, then you will go to rule number 2. So you choose the smallest duration. That means let's say activity A is 5 days. Activity B is 3 days. So both are slack of 2, 2. Then you come to the second one, you will resolve this issue of tie here. So you will take the duration which is shorter one, which means you should choose activity B because it's only 3 days compared with activity A of 5 days. So even though they have same minimum slack. So next, what happens if the number 1, number 2, they are the same? So let's say activity A got slack is 2, activity B is also 2, so both same. And then the smallest duration here, let's say activity A, the duration is 5 days, B is also 5 days. So it becomes 1 and 2, they're all same. So both having the same values, then how to resolve this tie here will be based on number 3. And definitely this one is going to solve the problem. So based on what? The lowest activity identification number. So you see number 1 and 2, both of them A and B having the same values. Then the only way to solve it will be the lowest activity number. That means in this case, A and B, you will choose A to put into your load into your resources first. So that solves the problem. So this is called rules of thumbs, or we call it heuristics. So next, using this approach, you apply this method called the para method. So this para method is used to apply this heuristics. So how you apply this para method? This is called an iterative repeating process starting at the first time period of the project, and you do the scheduling period by period, one period of time by one period of time, one by one, from the starting of any activities using these 3 priority rules. Based on these 3 rules, and then you repeat, go and do the scheduling from period to period. So this whole process here, this is called parallel method. Okay, so the heuristic is the 3 rules here. Okay. Now we look at one example to help you understand. So this is an example of a resource constraint, a problem that how to solve it. So you can see this center of 2P here. Let's say this is an example about you need programmers in your project. So 2P means you need 2 programmers. Okay. So this one, the one that you have activities 1, 2, 3, 4, 5, 6, and 7. So activity 1, you require 2 programmers. Activity 2, you have 2 programmers. 3, 2 programmers. 4 is 1 programmer. But you can see is 2, 3, and 4, they are what? Parallel activities. You can start at the same time. You can see it start from 2 to 2 here. Early start, they are the same. So that means at the moment you start active, you can have start 2, 3, and 4 at the same time. And you need how many programmers now? You see 2 plus 2 plus 1, you need 5 programmers. So what happens if the number of programmers you have, the maximum you can have is 3? Then that means you cannot start activity 2, 3, and 4 at the same time. So you have to decide which activity I should go and start first based on the constraint resources of programmers I have. So next, you also can see this followed by this. This is the sequence. Okay, so this one is the technical constraints. That means after activity 1, then followed by 2, 3, 4. Then after that, 2 will go to 7. And then from 3, it will go to 5, and then go to 7. 3 also go to 6 and go to 7. 1 go to 4 and then go to 7. So these are the dependencies, the technical constraint. So you're looking at this network diagram here, you will see this activity 1 go to 3, go to 6, go to 7. This is the critical path because the slack, they are all 0. Okay, so now you got this constraint problem now. So that means the first activity you got no problem because you got maximum of 3 programmers. You only need 2, so there's no problem. But when you come to activity 2, 3, 4, then you have a problem you must know how to solve this resource constraint problem, because you need 5 programmers instead of what you have 3 programmers only. So how to solve this? So you're going to apply the heuristics, the rules of thumb. Okay, now how to do this? You look at this one here. So based on just now this diagram here, the network diagram, you just put all the information, you load it into this diagram here. Okay, this chart here is called the resource load chart. How you plot this chart? So you just draw this table. The first column here is called the ID. So you just put this ID, this box here, which is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, the ID of the activity. So the next one is the resource. Okay, the resources you require. How many programmers do you need? So you just load from the center box. The first activity 1, you need 2P. That means 2 programmers. So number 2, activity 2 is 2P. Next one is 2P, 1P, 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 1P. Okay, so this one is the number of programmers you require for the resources column. So next, duration is very easy. You know this is the duration. That is the legend here. You can look at this legend here. You know this is duration box. The last one, the center one, the last row center value will be the duration. Just put in, just copy, take this value and then put into this duration column. So next, you take the value from early start. Early start is the first box at the top right corner there. So you take the value, just load into this chart here. Next, you have the late finish. Late finish is the last box at the right hand bottom corner here. Take all the values and load inside here. So you have the 2, 10, and then you have the 6, 10, 10, 10, and 12. Okay, next, what is the slack? Let's look at this one here. This box is the slack. Just copy all the slack and load into this chart as well. So once you have finished this, now you start to look at the resources you require, and then you distribute according to the time period that you require. So remember, you see the first activity is activity number 1. You need 2P, 2 programmers. So what is the duration? Is, let's say, assuming this is 2 days. So here, that means this is the first unit of time, 0 to 1 is the first day. You need 2 units, okay, 2 programmers. So you put 2 here. And the second one also you need 2 programmers. So you have 2 programmers, 2 programmers. So that is the number of programmers you require for the first activity, which is duration of 2 days. So you put here. Next, followed by the 3 activities, 2, 3, and 4 here. So same thing, you just spread across the duration. So activity 2, you need 2P. You spread along how many duration is 6. So you start from 2, 2, 2, 2, 2, 2, 6 unit of 6 days here, right? And then you see you got a slack of 2. So behind this is called the slack, the empty one. You don't need any programmers. Next, for activity 3, also you load inside is starting from unit 2. You also have, what's the duration? 4 days. That you put 2, 2, 2, 2. And the next one will be activity 4. You also start at unit time of 2. And then you need 2 days, so 1, 1 each. And followed by 5, which is starting from unit 6, the time 6. Then you have 1, 1 here for duration of 2 days. Then the activity number 6, you have need 1P, but for 4 days is 1, 1, 1, 1. And the activity 7, which is 1P, and you are starting from the unit of time, the early start is 10. So it's 1, 1 here. So you can see your ending is 12, okay, ending on the 12th day. So you can see the last row here is, which is the total resource load. That means total resource programmer that you require for each period of time. So the period 0 to 1, you need 2P. 2P, then you can see is 5P, 5P, 4P, 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 and then 1P, 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 1P. So you can see during this part here, you don't have enough resources. If you have maximum 3, you need 5. So you cannot cater for 5, and also the period of 4. So now you are learn how to solve this problem now. So this is the guideline, which is called the heuristics. So you do the scheduling 1 period at a time. So can you see the text that I give you in the PowerPoint, your PowerPoint? Is it very tiny? Can you see that this explanation, this slide here, about period 0 to 1, and then what you do? Can you see that slide?
Can see, Doctor.
Okay. Yeah, did you, it's better if you,
Yes, Doctor.
if you print out that, you can follow the diagram. Okay, let's see. So we will do this, you have to follow this step by step. This is called heuristic. It's quite complicated. So now we look at the figure 8.4, which is scheduling of the activity 0 to 1 period. We start with activity 1. So just now you mentioned that this is the first activity, so there's no other predecessor in front of activity 1. There's no activity, so you just need to load 2p here, two programmers here for the first period of time, and you have 2p here. You are not exceeding the resource available, which is 3p. So you have more than enough. So for the first 2 periods, no problem, just load inside. Now we come to the period 2 and 3. We study 2 and 3 now. So that's why you do period by period. First 2 periods, no problem. Okay. So now we come to this one here. You can see starting from 2 to 3, you need 2 programmers for activity 2. You need 2 programmers for activity 3. You need 1 programmer for activity 4. So you need total 5 programmers, but maximum you have only 3. So which are the 2 activities you can load? You can start and then you can use the programmers. So remember the heuristic. Heuristic says what? The first rule says the minimum slack. Now you look at the diagram. Which one has the minimum slack? So you go back this diagram here. This one here. So you can see which one got the minimum slack, which is activity 3, 0, right? So if you load activity 3, then you need 2 programmers. So after loading 2 programmers, then you look at which one got, next one is which got the minimum slack is number 4, is number 2, which is, but it's 2 units of programmers. So total will be 4 programmers. Then you only have 3, which means activity 2 cannot be loaded into the resource chart. You can have start with 3, but cannot choose 2 or those slack. You have the slack of minimum compared with the activity 4, which is 6 slack. The minimum is 2, but you don't have enough resources. So instead of you put 2, now you put 4. Understand? So you put 3 and 4, which you need 2p and 1p, total maximum of 3p. Right. So now you go back. So you can see here, that's why activity 2 is delayed. You put a cross here. So this 2 is loaded for activity 3. You put in for the next period 2 to 3. And then the period for number 4 is also loaded into the resource chart. So you have total 3p and you got the verbal of 3p here. Exactly maximum you can have. So now, because you delay this, then your early start of activity 2 will be cut. Delay 1 unit of time becomes 3. So the slack of 2 units cut 1, because you delay 1 unit, then become 1. You understand? So after you have scheduled this period 2 to 3, then you move on to 3 to 4. So remember, just now make the assumption that once the activity has started, you cannot go and stop and then go and put another activity and then come back and continue with that activity. So that means once this activity started, you have to continue and this until this activity finish. So you put back this 2 here, put 1 here. So this is 2 units of time. So this one completed. But this one is 4 units time. You put all the 2 here. Understand? Okay. So when you're looking at this, okay, so if you go back and look at the explanation here, so you can see 2 to 3, the explanation given in the text says, activities 2, 3, and 4, they are eligible to be scheduled for this into this resource chart here. But activity, you can have activity 3, which has the least slack 0. So you put in, apply the rule number 1. Then you load the activity 3 into the schedule here. Activity 2 is the next with the slack of 2. However, because activity 2 requires 2 programmers and then you only have 1 programmer available. So in that case, you go and delay activity 2 and then you go and put the activity 4 inside and you delay the ES to become 3 and then the slack become 1. So that's just now what I explained here. Right. So next, you see the next eligible is already mentioned is 4. You put inside and exactly you have 1 more programmer and then you load activity 4 and then put into the first unit. So this is the diagram 8.4. You go and go into the schedule, the period for 3 to 4. So when you come to 3 to 4, so activity 2 is eligible, okay, but because still exceeding the limit of 3 programmers to in the pool, so you delay activity again. Okay, when you come to 3 to 4, you cannot have activity 2 again because this is still taking 2 and 1 here maximum. So you continue to delay the activity 2. So you minus this early start and become 4. And then the slack becomes 0 because just now was cut to 1 and 1 cut 1 becomes 0 now. Okay, so you can see that is for 3 to 4. Next, you schedule 4 to 5. So when you come to 4 to 5, activity 2 is eligible for the but then again, it's still exceeding the number of 3 programmers that you have in your pool. So again, you cut again. So this activity 2 update to become early start become 5. And then the late finish become 11 and slack become -1. So because it's already no more slack, so your late finish become 11. So and then now you see it will go to activity 7. Why activity 7? Because after 2 finish, it will go to activity 7. That means 7 is affected by 2. If 2 is delayed, 7 will be delayed. So here in this case, you must go to look at activity 7. You update this activity 7 by early start originally is supposed to be 10. Then you delay, you put a cross here, then become starting through 11. Okay. And the late finish, because it's delayed 1 unit, so originally supposed to be 12, it will be delayed until 13. So the slack become, it was a slack you have, the original one, you have the slack of 0, then become -1, delay 1. So become -1. So next, you move on to period 5 to 6. Now activity 2 is eligible, but still exceed the limit of 3 programmers you have. So now again, you delay the activity 2, you cut again, you update the early start to become 6. So you cut again, continue to cut, now become the 6 here. Okay, and then your late finish, you delay again because becomes 12. And your slack -1 again become -2. So next, you delay the activity 7 because after 2 is activity 7 is affected. So you update activity 7 again. Early start become to, supposed to be just now delay become 11, now become 12. So the late finish just now was 13, cut again become 14. So the slack was -1, now be increased to -2. Okay, so next you move on to activity 6 to 7. Now, when you come to 6 to 7, the activity 3 already completed. So now activities, what are the activities eligible? It can load the resources. You will have activities 2, 5, and 6. So they are eligible with the slack of, because you got -2, 2, and 0. So these are the slack value you have. And then you will look which one. The minimum slack this time will be activity 2 with -2. So now you load activity 2 into the schedule according to rule number 1. So because activity this 6 here has 0 slack, it is the next eligible activity. You have -2, 2, and 0. So -2 load inside, which is activity 2, then followed by the 0 slack, which is activity 6. So now you load activity 6 into the schedule using rule number 1. So the programmer limit is still 3 now. Maximum you have is reached. So now you delay activity 5 and you update the early start becomes 7 and the slack becomes 1. So next, you have enough maximum of 3 period, cannot do anymore. So you move on to the next period, which is 7 to 8. So for 7 to 8, the limit is reached. You cannot add anymore. So no change, just put back all the things there. And then you have no programmers available. So you just delay activity 5, updates the early start to become 8, and then slack is become 0. Okay. So you understand? So that means this is using this method. You consider every period one at a time. So you follow this explanation, then you will see towards the end, you will end up with this. So you see, this is the how you do the heuristic and the parallel method. So you keep on delay, cutting, and then you meet all the requirement here. So this is called the resource constraint scheduling. So in the end, when doing this approach until you finish everything, you will see there's a delay. It's supposed to finish at 12 days, now become 14 days, delay by 2 units. In order to fulfill to make use of maximum resources you can have. You cannot have 5 and 4, the original chart. You can only have 3P. Because of not enough resources, you delay the project. Okay, and but you make use of the 3P maximum you can make use. So throughout this duration, but then there was a delay of 2 days at the end of this resource scheduling. So you keep on cut, you see there's a way. So this is quite complicated. You have to do it slowly and then follow the rules, looking at the slack first, and then you look at the duration and look at the ID. So these are the 3 rules that you follow slowly, and then in the end you end up with this. So delay of 2 days. So now after finish this, now you come back, you plot this one. Okay, so you can see you plot this. Now it's called, this is the new resource schedule network. Originally, remember, it's ending with 12 days, now ending with 14 days. So now you can see just now it was the activity was originally, what was the critical path? It was from 1 to 3 and then 6 to 7, right? You see, if you look at the original one, original is 1, 3, 6, 7. But now, after the resource constraint problem that you solve, now you look at, okay, now you can see, now here, 1, 2, 7 critical path. 1, 2, 3, 5, 7 critical path. 1, 3, 6, 7 is also critical path with all the zero slack now. Okay, so you can see because of resource constraint problem, and after using this heuristic approach, you solve the problem and then you ended up with more activities become critical activities, and then you got more critical path, and that's a delay in the project duration. And now you look back the thing, you can see you solve the problem now. You solve the problem by delaying all this activity time here. So you can see now, so this one is, you don't go and adjust because you can say this one 2, you are no more putting 2 here because of resource constraint. So you delay this, become starting from 6 instead of just now the original one, which was 2. You understand? So this one, these two start together, but this one was delayed until 6. And by doing this, you ended up with 14 here. And this chart here is called resource schedule network. You see, this is a network diagram, but it's based on resource scheduling. You understand now? Okay. Okay, so that you can see is quite complicated, right? Very difficult to do. So, but fortunately, there are computer software that can cater for this plotting of resource constraint scheduling. So look at this example here, the computer demonstration of resource constraint scheduling. So this is a project called EMR project. So it's a development of a handheld electronic medical reference, EMR, guide to be used by emergency medical technicians and paramedics. So this is the problem here. There are only 8 design engineers. So in this project, you require design engineers, but you can have maximum of 8 design engineers only, who can be assigned to the project due to a shortage of design engineers and their commitments to other projects. So they may be needed in other projects as well, but you can have maximum of 8 of them. So now this is the diagram here. So this is the computer plotted one. So in this computer software, it can plot this, showing this is the architectural decision. So this is the activity of this node here. When is the starting date? What is the ID of this node? And then when is the finishing date? What is the duration for this activity? And then RES is the resources required. So you require design engineers, but here they put 500%. 100% means 1 person, 1 design engineer. 500% means you need 5 design engineers. So here, the second one, actually 3 here, 4, 5. You need, this one is 500% means 5 design engineers. This one, 4 design engineers. This one, 4 design engineers, and so on. Okay, so this is plotted by a software, computer software, and you're ending on the finishing day, which is February the 14th. Okay, you started on the 5th of January, finishing on the 14th of February. So here, this is the flow. You can see the flow here, that one that is in blue color is the critical activity. So the critical activity is from 2, ID 2, go to 5, go to 9, and go to 13. So critical activity is 2, 5, 9, 13. So now because not enough design engineers, first one you have 5 design engineers, enough. You got maximum of 8. So it's enough to cater for your needs. Now the second one, the activity 3, 4, and 5, you need 5 here, 4 here, 4 here. So 8 plus here is 5, here will be 13. So you don't have enough, maximum of 8. Now you need 13 here, you see. So you don't have enough. So you now have to do resource constraint scheduling. Okay, now this is a software that first will plot for you. Just load in all the information, the task name or the activity name, the starting date, the finishing date, the late start, the late finish, the free slack, and the total slack. So you can see, remember just now the critical path is from 2, 5, 9, 13. So you can see this is the flow here. And this bar here, it shows this is the blue one is the critical path. And the duration of this gray one, these are the tasks. And this is the bar here which shows the slack. And this, the highest one, the black one, is the total duration. Okay, so you can see those lines with this length here, it shows that these are activities with slacks. The one that do not have is without the slack. So this one immediately followed by this, but this one got a slack, this one got slack, and all this got slack here. This one no slack, and straight away start this last activity here. So you can see also from here, okay, which one got slack and which one got no slack here from the total slack there. So after you plotted this one, this is using the MS project. You plotted this original one. Now you have to do scheduling. So this software will help you to plot. So this is an example for just one part, a portion of this project, EML project, just starting from January the 15th and then ending with January 21st. So in this diagram, this one is illustrated using the number of hours that require to work by these design engineers. So this is the total. 3024 hours is the total time that require to work by these design engineers from the period January 15 until January 21st. So for this architectural decision, that is the first node, you require, this is the number of total hours work. And then of course it's distributed across the period, but it's not shown here, it's not needed within this period. And then for internal specification, total is 480, but it's spread across this period, you have 40 hours here. And external spec along this period is not needed, maybe other periods, okay. Feature spec, you need 32 hours for this on this day, January 15, and so on. So this is a portion only, not a complete one. So here, if you add up this 40 hours plus 32 here is the total of 72 hours on the 15th of January. So on the 16th of January, you need this one here, 40 hours, 32, 16, 24, 24. Some of this is 136 hours. Okay, and some of this for this period is these are the hours here. So by looking at this hour, for example, you can see this 168, 168, this one is 70, 136. So one day, the working hours they calculated is based on 8 hours. So the total number of hours divided by 8, then you will know there how many design engineers you require. So in this case, you can see 168 if divided by 8, the number is 21. Okay, so now you can see here, you convert to this chart, this diagram here, this table here, convert to the number of design engineer required. So divide 72 by 8, then you require, this one is what? 9 engineers, design engineer require for this period, 72. Okay, 9 times 8, 72, right? Okay, so you put here, and then this one, 136 divided by 8, you get 17. 168 divided by 8 is 21, and so on. So you look here, this day, January 15, you require 9 design engineer. On the January 16, you require 17. But you only, this line here, it shows maximum you can have will be 8. Okay, 8 design engineer. This is the allocated. So this is the gray bar. Over allocated means this is the not enough one. Okay, you need this number, but this bar here, this part here, the blue one, shows the number of engineers that is not enough to cater your needs. So again here, you will do the levelings. Okay, so when you apply levelings, it may not be solving the problem because you need maximum of 21. So because of that problem, resource constraint, you apply the heuristics, rules of thumb. So after you apply rules of thumb, and then this software will help you to plot the chart again. So after they reschedule the thing, and then the critical path become changed. So originally it was 2, 5, 9, 13. So after rescheduling this thing to cater for your needs that you have, then it changed become to 2, 3, 9, 13. So using the software. Okay, so now become critical path changes, but it's not, we cannot call it critical path because after the resource constraint scheduling, it end up with, you see, this is the one that critical path, the pink color. So you have here, which is 2, this one is 3, this one is number 9, and the last one is number 13, ID 13. So you can see they are not continuous. So here, you go to here, but this one is not going, you see or not? So this is not coming to here. This is go to another place, another task. So this become is not critical path, but you call them critical activities. So you end up with critical activities. The path is no more continuous. You call it 2, 3, 9, 13. Okay, of course, in between they got other paths that make them join back. Okay, but they are not continuous anymore. Okay, you see or not? So you don't see all the bar continuous and then here, but they are become critical activities instead of critical paths. Right? So this is plotted using the software itself. Right? It's quite complicated. So that's why in my test 2, this question will not come up. It will take a long time for you to plot the charts. I will ask some simple questions, right? Okay, next. So after learning this resource constraint scheduling, so what are the impacts of having this? So you can see very obvious that it reduces the delay, but reduces flexibility. You make use of the slack. So those that it was having a lot of slack become no more slack. And because of that, it increases criticality of events. See, some activities, they were not critical, now become critical. And it increases scheduling complexity. You can see the scheduling process is very complicated. And this may make traditional critical path no longer meaningful. So originally it was 2, 5, 9, 13. Now it's changed, become 2, 3, 9, 13. And then it's not a continuous path. It's just they are activities. So you can see it can break the sequence of events. Originally it was connected. Now it become not follow the same sequence, become another type of sequence. It break the sequence. The path is no more in the sequence. And it may cause parallel activities to become sequential. You see, originally they are parallel. Now it become, because of this resource scheduling, it end up with parallel activity cannot have parallel. It become sequential, one after another one, finish to start. And the critical activities with the slack to become non-critical, it can be. So those originally they are critical activity now become not critical anymore. So originally there's no slack, become it have slack now. Okay, so after scheduling, all kind of things can happen. Okay, so that is a resource scheduling. You can see it's very complicated, right? So next, there's something called, you're going to split the task or split the activity, or also known as multitasking. So this is a method here in real life. So a scheduling technique used to get a better project schedule and or increase the resource utilization. So you do a splitting, you split the task. So this involves interrupting work on an activity to employ the resource on another activity, then returning the resource to finish the interrupted work. So just now the example says, once activity started, you cannot stop and then you come back and continue, resume. No, but in real life, yes. So you start the activity, you stop it and then go and do another thing, or you come back and then resume. You can do this. So this is feasible when the startup and shutdown costs are lower, you see. So if it doesn't cost you a lot of money for you to shut down and then restart the thing, then you can apply this multitasking, or you call the splitting. So it's considered the major reason why projects fail to meet schedule. You see, because you start, you stop, you start again. You see, that will cause the delay in the project duration. See, it will cost longer time. So you look at this example here, this diagram, to show you the meaning of splitting the activities. So originally, this is the activity duration. Without, you don't split it. Okay, no splitting here. Next, you split it. How you split it? You divided this activity into activity A, activity B, activity C. So this activity duration got 3 parts here, or 3 segments, A, B, C. So what is this splitting here? You split what? You started with activity A, and then you shut down. You stop working on activity A. Okay, you stop for a while, and then you come back, you go and start the part B, and then you shut down, and then you go and do something else, you start up, and then with activity C. So you can see this is original length, okay, without any, don't split the task. You can see this is shorter time. But if you split into part A, B, and C, you can see it takes you longer time because you shut down and then start up again. So this active duration, if you split it with shut down and then start up, it will take you longer time. And because of this, it will cause the project delay if you apply this. Because if you don't have enough resources, you have to apply this technique, then you apply this. And it will resulting in project delay. So next, what are the benefits of scheduling the resources? So it leaves time for consideration of reasonable alternatives. So if you have resource scheduling in the early phase, at the beginning, you already consider that I may not have enough resources at certain time or period, then you cater for this. So when this thing comes, you already know how to handle them. So that's why you base on cost-time trade-offs. So remember, the longer time you take, the more cost is incurred. But sometimes you want to cut short the time, it will be, you have to pay for more. It's just like you do OT, you pay for people more money in order to get a job done faster. Okay, so you must have a balance between the cost and the time. So here, because of doing this, you have to change the priorities. So which task originally not so important, of lower priority. Now, because you need not enough resources, it becomes changing all the priority of all the tasks. So next, it provides information for time phase work package budget to assess. So you must take note when you do the resource scheduling, there are some problems that you may have to consider. For example, impact of unforeseen events. So you need certain equipment, but on that day, equipment down. It's just like the day the test one. So a few of the students encounter the problem, your system freezes. You cannot proceed with answering the test, you see. So that was an unforeseen event. So that will cause, you see, you cannot finish the test on time. So everybody submitted, but your system freeze. You cannot proceed with answering the test. So you must know what to do. See, what is the solution I should take immediately, because this is a test. So that's why eventually one of students telling me that the system freeze, when it was towards the end, you cannot submit. That's why you delay a few minutes. It was after the submission time. So because you informed me earlier, then I will cater for your needs. We still accept your submission. So you can see this is the unforeseen event that caused the delay. You understand now? So you can see it very clearly that happened to you. So same thing like during the searching of the MH370, and then the equipment that is used to search for the plane, it was dropped into the sea. Instead of searching using the equipment, that machine, to search for the plane, the machine itself is lost, it's missing. You have to, instead of searching for the plane, using that machine, that equipment to search for MH370, that plane, but you start to searching for the equipment which is missing, okay, down in the sea. Okay, so instead of searching for plane, you're searching for the equipment which is missing. So you see, these are unforeseen events. It will end up with delay all the search and the searching project itself, searching for the plane. So amount of flexibility in available resources. Again, also, how flexible can you move certain equipment? Like just now, the backhose. If you need that backhose for certain construction project, you got many construction going on. You have construction A, construction B. So both need the backhose. It's not easy for you to move the backhose from one place to another place. So backhose, if you're on the road traveling, is very slow. So how easy can you move that resources from one place you need to another place? So in fact, there's an incident happened in Malaysia. I think more than 5 years ago. There was a person, a man, he owns a few units of this backhose. And then one day he received a call from somebody. Let's say this is A is the owner, and B is the customer that order a backhose from this A. So this, because backhose is very slow if you travel on the road. So this B asked A, you go and put the backhose near a place. That place got some space that you can put, I need it somewhere near there. So you know where the person asked the A to put the backhose? He said you put somewhere near, let's say a bank. I think it's a Maybank, something like that. He said you put the backhose near the Bear Bank there, and then I will go and take the backhose later. Okay. So then the next day, after he booked this backhose, and then the next day, there is something happened. The person B go and rent this backhose for what purpose? Anyone can guess. The B rented this backhose from this A and asked A to put somewhere near a bank, Maybank. So can you guess, anyone can guess what is backhose was rented for?
To break into the bank.
Yes, that's right. So that person was intention to go and rob the bank. So that person B, using the next day, there was a police reported that there was a robbery in this Maybank, because the backhose was put just beside the bank. Well, the person said if he had to drive this backhose go to the bank, it takes a long time. So he asked A just to put there, and then so then he just like pick up the backhose. So he just used the backhoe, and it was just beside the Maybank. So he tried to rob the Maybank using the backhoe. Just want to go and drag this thing, the machine out from the Maybank. So the moment when he tried to pull the machine, the withdrawal money, that machine out from the bank, and then of course the alarm went off. So the person, this robbery was not successful. Then only that moment, the A realized that the B rented the backhoe from him was to rob the bank. Okay, so that's why you can see what is the flexibility and how many units you have, and then whether you can shift it from one place to another place easily or not. So these are the issues that I have to consider what the benefits of doing resource scheduling. So next, in real life, when a company doing a project, even when you are doing your study, you are not doing one project alone. You see, you got many courses and there are many projects ongoing. It's more than one. So this, you have to take note how you handle multi-project scheduling problems. Because there are so many projects ongoing, you will need a lot of resources. Project A will need this resource A, okay, and also resource B. So project B also need resource A, resource B, you see. So you'll be fighting over the same type of resources by each project here. So here, how do you handle this? So this first, we look at the problems. So this will resulting in overall project split page. You will split because this project A requires resource A. Project B also resource A. So which project will be given the needs that to fulfill your needs of using the resource A? So both fighting over the same project. That means one of the project is going to split. So you will split because of you don't get the resource to use and you will delay your project. So that's the reason a problem caused by the multi-project scheduling problem. So delay on one project, maybe one project you need this, and then you'll create delays for other projects. So like your tutorial group 3, all the teams, it will be you see all other teams, they already started the survey. The C-test one, they already started. I think the games one, I think already started, right? And then the one on the COVID-19 also already started because you don't depend on other projects. But the team 3, the tutorial group 3 students, all the teams from TG3, you are depending on my student's project. Yeah, her system for you to start and use for your HOTS assessment. So if there's a delay of her project, then it will cause your delay of your HOTS assessment survey, isn't it? So that will end up with delay of your data collection and data analysis. So maybe other teams already completed all their data collection and analysis, but you are still ongoing. So you will be behind time. And later you have a chapter to learn how to catch up, okay, if you are behind time. So that's the first problem. So next, inefficient resource utilization. So you can see the peaks and valleys of resource demands create scheduling problems and delays for project. You see, sometimes peaks means you got a maximum need. Then valleys means you go up and down, up and down. The fluctuation here, sometimes you need a lot, sometimes you don't need. So that makes a demand here giving you delay for some projects. You need maximum, but you don't have. And some, when it's varies here, it go down, you don't need it, then it's idle, it's wasting your resources. So become inefficient resource utilization. So next is resource bottlenecks. That means fighting over the same type of resources. So shortages of critical resources required for multiple projects cause the delays and the schedule extensions. See, if both projects or more than one project fighting over same type of resources, then some of the projects will be delayed. Okay, that's called bottlenecks. So next, how you solve this? So having all those problems mentioned just now, then what are the methods you can overcome this kind of multi-project resource problems? So this is the way here, managing the multi-project scheduling. One way is to create project officers, or we call the departments, office departments, to oversee the scheduling of resources across the project. That means you look one department that handle all the resources. You look at which department require what resources and when you need it. Then this department here will handle all the distribution of the resources to the different projects. Another one method we use is always called this first come, first serve. So you use a project priority queuing system. So which project is of higher priority, I give you first. So of course, that project that is ongoing, of course, you cannot say stop it and then you give to another project. If this project is also ongoing, is higher priority, you will continue to have given the resources required. So first come, first serve. So next is the centralized project management. You treat all the projects as a part of a mega project. That means you got many projects ongoing, but you put under one single project. That single project is called the mega project. It's the very huge project. Under this mega project, you put each project as sub-projects. And by that, you handle these sub-project resources. So you centralize the project management in this way. So another method is using outsourcing. So I will mention this method to you. You don't have enough resources. So you outsource projects to reduce the number of projects you handle internally. You don't have enough people, you don't have equipment or material, then you go to other people, subcontract, go outside, become outsourced. So what kind of project you outsource? Is it a project that is very important? You should outsource. outsource to outside people, contractor to handle for you, or your outsource project is not so important? What do you think? You should outsource important project or outsource project that is not so important? Which one will you choose?
Not so important.
Not so important. Yes, that's right. Because when you outsource project to another party, you cannot monitor the person, the contractor. So they may not fulfill your needs or the time frame that you set. So if you outsource, you must outsource the project that is not so critical. So anything that critical, you must within yourself internally handle the project so that you can monitor and control the project itself. So not so important one, you do the outsource. Okay, understand? Next. Okay, why? Next one, we come to using the resource schedule to develop a project cost baseline. Okay, so you have to start doing this because there will be chapter you are going to learn. The next chapter will be if you are behind time, what are the methods or approach we need to use to catch up. You are behind time, okay, or cost overrun. What do we do? So after this, then after that chapter, you will learn project progress monitoring. So how you monitor? You must have a time phase budget baseline. That means something that you base on. Okay, this is the basic thing, or this is the baseline you have. Based on this, you do monitoring and you make comparison to know whether you are doing very well, you are behind time, on time, or ahead of time. So this is why you need a time phase budget baseline. So this is to determine if the project is on, ahead, or behind your schedule and over or under its budgeted cost. So whatever you plan now, just now that diagram, it says, whatever cost estimation throughout the duration, time phase, everything, that is known as baseline, okay? Or we call it the plan value. Right? So to know how much work has been accomplished for the allocated money spent, the project cost baseline, which is called the plan value, is known as PV. You will use this for your monitoring and you make comparison so that you will know this one, the answer here, on time, ahead of time, behind time, or over cost, under cost, or on cost. Okay, so we will have a chapter on this, okay, 2 weeks later. So next, you are creating a time phase budget. So you assign each work package to one responsible person or department and deliverable. So each of these, remember the final value, the WP, the lowest breakdown of your PBS is called WP. This WP you can assign to one person, a owner, to own this task, and this person will know how much time given and how much money cost estimated given to complete the WP. So you compare the plan schedule. You see what you plan, your plan value, PV, and the cost using an integrated system called earn value. So this is what you're going to learn 2 weeks later, okay? There will be lecture on this earn value. So I'll explain in detail later. This is just an overview first. So for example, this is called a direct labor budget roll up. Okay, this is in 1,000. So it's 5,160,000, the total here. And if remember the one that you already studied in your diagram here, when the chapter on WBS, the crossing of the organization with the crossing of the WBS is known as work package. So this is the lowest level, and the crossing of this is the cost account. So this is the amount, the sum of this part here, where which department of this organization will contribute to finish this, all the WP within this part here, and what are the work packages under this part here. So the crossing of this, you get the amount called cost account, right? So this is already introduced in the WBS chapter. So from there, after that, you have to work out this time phase work package budget. So remember, each WP, you need to have one sheet of cost estimation, and time phase means you distribute throughout. So this one is in weeks. So that means first week, I need how much? Second week, I need how much? Third week, I need how much? So this is called time phase. That means distribute the cost throughout the time period that you require. So known as time phase work package. Okay. So you do this, you have to do this for your project itself. That's what I'm asking you to do, because you need this later in your plan value, the project monitoring, that chapter, and then you have to apply in your chapter 5. Okay, so this one just now, that example of just now, that one and this one, the difference is this one only have one WP. The next one, you have 2 WPs here. Okay, you combine the 2 WPs and then you put into here. Work package 2, put under one sheet of time phase labor budget for. This is the work package description is software, and this one is deliverable is the circuit board. Just now that one is the test and this one is also circuit board. Okay, but this example is 1 WP, second one is 2 WPs. Okay. Excuse me. Now we look at one example here. This one is a patient entry project network. You can see this diagram here. The task ID 1 go to 4, go to 7, go to 9 is the critical path because the slack is 0, 0, 0, 0 here. And the duration is 14. And you see this is the task description. Okay. Now, this one is called whatever your network, your system diagram here. And after that, based on this, you load this. So you have to take note. I think each team must take note that you have to start allocating. Remember, you have the cost estimation. So for this design, I just extracted part of this to explain to you. So for example, the task number 1, ID 1, is called the design data system, is put here. So you can see this duration is come from this box here, is 1. This is the box duration. 1, 2, 3, 5. Okay, 1, 2, 3, 5 for activity 1, 2, 3, 4. And this is the task name. So where is this one come from? Remember, you have done the WP cost estimation. So this is where you get from there. Okay, the WP cost estimation, and you put here. And because this duration here, you can tell this is the unit of time. So this is, let's say, the first unit of time you only need, you allocated, this one is 1,000. So this is $5,000, and it will use $5,000 for the first unit of time. So this is cumulative. So 5 here and put down 5 here. So the second unit of time is the activity 2, 3, and 4. So activity 2 you have allocated is 4,000. So this one is 6,000, 3,000. So you put here, but the activity 2 you need how many units of time is 2. So it start from the unit time 1. Each one also 1, 1, 1 here. So all same together this time here. But this one is 2 unit of time, 2, 2 here. Total is 4. So these 2 add up become this one. This one add up 2, 2, 2 add up become this 6,000. And this one only 1 unit of time, and this is 2 units of time. It's 2 units of time. And sorry, it's 5. It's 5. So you only need to use, you see. So this one here is you need it here, and the cost allocated is 3,000. So unit of 5 unit of time is 1, 2, 3, 4, 5. You only need it for the first unit of time here, 1 to 2. But in between you don't need, and then you only need another 1,000 is the unit of time 5 to 6. Total up 2 plus 1 is 3 here. Okay. So in this case, you have to plot this later when you come to chapter 5. You just load all these things is from your network diagram. And this is the budget from your cost estimation you put in. And then you go and distribute across the duration, the time frame. This is time phase. Which period you need the money. So the sum of along this row must be the total of this one here. Understand? So you do this. And then here this is cumulative. You see 5 put here 5. This is total 2, 2, 2 is 6. Just 5 plus 6 is 11. So it cost this way is cumulative. So the final one, the total amount is 52,000. So this is called your baseline. You understand? It's called baseline. So this is called cumulative baseline budget, PV. Okay, it's called PV, plan value. When you plot this, you can see this value here, 5 cumulative, then you see the graph. So that means this is cost. Cost incurred, you see, as you go along the project progress, then you end up using the final total amount is 52,000. End up this point here. So this is called your baseline plan. Okay, so take note of this. So you need to monitor doing your project as you go along. What is the cost incurred? And then it will distribute throughout the period according to the duration you have and which period you need how much. So the sum of each row must be come back to the amount here. Must be the same. Okay, understand? So you need to do this when you come to chapter 5. So after having that, you can also plot a chart which shows the cash flow. That means at certain point of time, how much cash money you require. So this is the project here, CEBOO project. And this month, how much cash flow from which part, that item that you require. So you can do this part as well. But in our chapter 5, you don't have to do this because we don't really see the cash flow. Okay. So next, after having that, you can also have this, the resource usage scheduled by the staff. Okay, this person, Suzuki, okay, you need a hardware specification for this period, how many hours this person will spend working on this. So this is in terms of human resources that require and the the number of hours required by this manpower. Okay, so you also can plot this based on those things. Okay, so we are not plotting the last two charts. Okay, we only want to do the plan value and then the monitoring. So later you're going to learn earned value analysis, which is a very important technique in project management. Okay, so today that's all for this resource constraint scheduling and the time constraint, how you solve this time constraint problem and resource constraint problem. So these are some key terms here. Any questions so far? Yes? Anyone? So to understand that just a constraint, resource constraint is more difficult, you have to follow just now that page of explanation. Using the heuristic approach, apply the parallel method. But in my test 2, no doubt this is calculation, but I'm not setting this question because it's too complicated. It takes a long time to do the scheduling. So you cannot finish in 1 hour if I set a question like this. Okay, but I'll set something simple that asks you some, let's say for example, what is the method you use in resource constraint? Then you will know this is called the parallel method using the heuristic approach. Okay, you understand? That kind of question. Okay. Any questions so far? But I'll give you some question to practice. Yes.
Doctor, this is a question that's not related to lecture, but I think it's still important to us. For the lecture attendance, I think the sheet for the December hasn't been created yet.
Oh, okay. Oh, sorry. Okay. I'll go and create in the short while. I thought I created, or maybe I forgot to drag into the folder. Okay, I'll check that afterwards, and then I'll put in, and then you just take note of the attendance first. Okay, after the lecture, give me about maybe like afternoon, I'll get it done. Okay.
Yeah. Thank you, Doctor.
Okay. Yeah. Thank you for informing. Okay. If no question, maybe I want to show you something, a beautiful true story, and after that, I'll answer all the questions from all the team leaders who sent me a lot of questions until I really got no time to answer. So I'll answer after this. Okay. After I show you this, the beautiful true story. Okay. Let me show you let me see how I show this. I will switch the screen first. Okay. Okay, can you see this? Can you see that one? Can you see this one? Can you see the beautiful true story? Can or not? Yes?
We can.
Okay, good.
Yes.
I use the read feature.
Doctor?
Is that supposed to be audio or?
Doctor, we cannot hear the audio.
Sorry?
Yeah, we can't hear the audio.
Here.
Yep.
Just a minute. You cannot hear, but you can see, right?
Yeah, we can see it.
Okay. Maybe you cannot hear. Maybe I'll read to you. Okay. This one is. Yeah. I think I also drag the file into your, our lecture, the main link, the post beside that. There's a file. I drag inside there. This one is a true story. A very nice story. So in England in 1920, there was a graduation ceremony for a batch of new doctors. It was attended by the British Prime Minister of that time in 1920. So during the ceremony, the dean who was in charge of that batch gave the necessary advice to these new graduates. So he told them the following incident, which happened with him some times back. It was after midnight, and I heard a knock on my door. It was an old lady, and she said to me, "Oh, my doctor, my child is sick and in a very serious condition. So please do something to save him." So I rushed out to follow her to her house without worrying what will happen, because it was a stormy night, a heavy storm, and very cold. The rain was pouring down very heavily. I did not fear for my life. So her house was on the outskirts of London, and after a difficult journey, we reached her house. She lived in a small room with her son When I entered the room, I saw her son at the corner of this room, rolling and deeply in pain, so very sick. So after I did my duty towards the sick child, the mother gave me a small bag with money. I refused to take this bag, and I told her gently that I can't accept that payment because I felt so sorry for their situation. They are very poor, okay? So the doctor didn't want to receive the money. Then I promised her that I will take care of her child until he gets better. The dean continued in his speech by saying, "This is the true profession of medicine, and being a doctor is the closest profession to mercy and one of the closest to God." So as soon as the head doctor finished his speech, the Prime Minister jumped out of his seat and headed to the podium. "Permit me, sir, to kiss your hand. For 20 years now, I am looking for you. I am the child you mentioned in your story just now. Oh, my mother will be happy now, and she will rest in peace. Her only wish was for me to find you and to reward you for that goodness you did for us at the time we were living in poverty." That poor child who became the Prime Minister of England was Lloyd George. So plant goodness wherever you go, even if it is not on your place, because it will never get lost wherever you will plant it. It is even more nice if your goodness lasts longer, because no one shall harvest that goodness except the one who has planted it. So doing goodness to others will always purify your heart, and will fight any kind of evil which comes your way. The owner of goodness does not fall. If he falls, he will fall on a pillow to comfort and support him. Thank you. Okay, so it's a very nice, true story. So we know that we always have a good heart to help people, and you will be blessed. Okay, there's something to share with you. Okay, so I will end today's session here, and then I will answer all your questions from many of the team leaders who sent me a lot of questions. So anyone to start first? Anyone?
Question.
So what I want.
For the presentation, it's supposed to be 30 minutes per group, right?
Yes, that's right.
So is anything lesser than 30 minutes will make our marks be deducted?
Okay. No, but you see, you need to present whatever I mentioned in my guidelines, which is you have to cover chapter 1 until chapter 3, right?
Yeah.
So as long as you cover all these contents, you are okay. So
All right.
another advice is, let's say your team, you have 12 members, right? But you can see the content is not enough. You don't have to assign half, you know. You can say, oh, I got 12 members, so this time I assign 6. Next round, I assign 6. But you can see that if content chapter 1 until chapter 3 is nothing much for you all to present, then you don't have to assign 6 team members to present. You assign maybe 4 only or 3 only. Then the others will present in the next presentation, which may have a lot of content. You understand? Then you get then you will get good grades because the contents carries the most marks.
All right.
Got the idea now?
Yeah. Thank you, Doctor.
Yeah. So you can finish less than 30 minutes. Let's say you finish in 15 minutes, but you only have 3 person presenting, and these 3 person presenting a lot of content. These 3 person will still score. Okay. But don't go and assign, let's say 7 or 8 person out of a 12 person to present just 3 chapters. I think you'll end up with very few marks only, because the content will be nothing much, because you assign too many to present a content which is not much to say. Okay. Understand the trick now?
Yeah.
Okay. Second question?
Doctor, I want to ask something about presentation as well. Last time you mentioned that we should record a video on it, and you mentioned about the group leaders and the members should be around so that I can introduce them during the presentation. But there's not all the members that involved in the presentation. So in the video, should I include all the members inside?
No need. Is no, you when remember the I wise okay, the first mistake you make is presentation, not presentation. Okay. So
Okay.
take note of this, otherwise marks will be deducted. Okay.
Mhm.
So now first thing is you look at the content. Let's say you got 12 members and you only assign 4 members. But remember I say that when you come up for the first presentation or second, the team leader always have to introduce all the team members, right? So when you as the team leader, when you introduce all the team members, you show the slide with all their photos. Then after that, you just mention in the first presentation, I only have 4 team members going to present. Do you understand?
Okay, I understand. Doctors, I want to ask about for the projects because I have sent you, I believe it's twice, so that I still did not get your review. So
I ask you to ask now because I got no time to answer. I know there's so many emails coming in because I got other things to do. Because my master student, they are having Viva, and then you see the tutorial group 3 that you need the Vivian system, you see. That's why I've been working with Vivian to finish her system, rushing for the system so that tutorial group 3 can use my final year project student system to go and conduct the HOTS assessment. Because if her system got errors, then halfway you will get into trouble that system cannot capture the data, then all your effort will be wasted. That's why I was quite busy the past 2 weeks and then handling my postgraduate student and also the final year student to rush for that one because there's a dependency. The tutorial group 3 student all dependent waiting. You see, just now you already mentioned technical constraint. You require my student system. So I need to rush. My final year student, she is also doing her final year courses. She also rushing to finish her project because final year project is part of the component she has to submit because she also has deadline. She also has to conduct testing because this our tutorial group 3 need her system as soon as possible. You see, that's why I just now mentioned all other teams started the survey because you use Google Form or SurveyMonkey. You don't need other system to depend to for your data collection. But tutorial group 3, you need her system is because they got some timing where existing that kind of Google Form cannot set timing for answering one question with certain time limit, 2 minutes, 3 minutes like that. That's why you need a system for your data collection. And this system comes from my final year project student. So I have to help her to do all the system testing and so on and make sure that no more error. And after that, we do the setting up, you do the testing again. So you can imagine a lot of time I had to spend to help her and do all the checking until we are quite confident. So that day when I asked her, any one of you encounter problem and reported to her, I know some of you got some missing item, some fields that the department you want is not in the system, you see. So I asked her to add all this, make the changes. But I think basically her system is working fine. I think she told me that that's why I asked you to do UAT, user acceptance test. So far, she told me no errors that reported by you. But from the UAT, which is good, because I realized that some of you go and choose to answer as a guest instead of log in as student. So if you log in as guest, we cannot capture the data we require for the data analysis. So that's why that day I asked her again to remove the guest login and then change it to without the guest. So the system now don't have guests. Everyone must log in as student so that we can capture all the data for your data collection, the HOTS assessment score, and so on. And because of that, you see, she had to do the changes, and then I will keep on contacting her and do our thing monitoring. So it takes a lot of time. And besides that, as I mentioned just now, I also have PhD students, our master students. They also presenting, they also sending thesis. I have to check all their chapters because they're sending out for examiners to examine, which is critical. So if they don't do well, then the examiner will fail them. They have to repeat the Viva, they have to repeat the thesis. It costs them longer time and money. You understand? So remember, cost time incurred here if they fail, their Viva or the project they submit to the external examiner. So they'll be in trouble. So I have to handle all the others. And also I got a lot of meetings to attend. And also overseas asked me to be the paper reviewer, conference reviewer. I have to read the papers for them and give my comments. So it takes me a lot of time. And other students also applying to study overseas ask me to write recommendation letter. So all this takes up a lot of my time that they all need it all urgently. So I have to go and handle the urgent one first, become that I slow down your request that you send, ask me to check this, check that. So that's why I say I decided to answer all your questions now instead of I answer through email because I type a lot. So if I answer quickly, I can give you the instant reply from me. I will clarify whatever you want to ask. Okay, so if you got any question, got any diagram you're not sure, you show me now and I will check for you now. Okay?
Okay, then I share my screen right now, Doctor.
Yes, yeah, sure. And the other team leaders, you can look at, if this is the same in the same group and you're doing the same project and the question this Wei Yong is asking is same as what you want to ask, then I don't have to answer your question again. You see, so we can solve all the problem by one person asking and others can share the answers. Okay.
Yeah, Doctor, so I want to make sure that my project teams, right, I make it in this kind of format. Is this
Yeah.
acceptable?
That's why I realized that there are some teams they drag, the everything they put inside in one table, but it's taking a lot of space and it's it's like the margin setting is out of the margin setting. So it's good that you break it down into, let's say this is the team, you go scroll up just now. First is all your team members, the roles and the contact number. Then you break into the second table where it shows all their roles and responsibility in detail. That is good. That means you are creative. It's good that you know that my margin, you will be out of margin. If you put these two together, definitely you'll be out of the margin setting, right?
Yeah, that's why I feels like I don't have enough slot. That's why I create two tables for it. But I don't see others do like that. That's why I change it.
You don't worry. I'm very impressed by the way that is called creativity. So you know that this is a problem. I cannot have all the things in table which will be out of the margin. So how I solve it? You solve it by breaking it down into two tables. That's good. That shows that you know how to solve a problem creatively. So you have creativity. Okay, good. Yes.
Another problem is my measure deliverables. I make it in this format. Is this acceptable?
I will prefer that, the format most of the teams they use is first you break down into what are the phases, and then this phase, what are the deliverables. That would be better.
So
input in table form. Okay, so your this is what phase? Completion operation. This one is the description already. So this is under which phase? Like 1.3.1 is under which phase?
My phase is just like this one, completion of platform, completion of survey form. Yeah, this is my phase actually.
This is the first line is your phase. Then the second one.
And the down one is like some description as well as the deliverables. Yes.
You put it tabular format is better.
So I just change it to tabular format.
Yes. So you got at least two columns. So you can put 1.3.1. Then underneath is completion of platform, selection for survey form, and then the second column on the right hand side will be this description.
Okay.
Put select deliverables. Okay. Yeah.
So I have one more subchapter which is exclusion and limitation. Is this okay?
It's okay. You can include this. Yes.
Okay.
Should be before the priority matrix.
Before project priority matrix, right?
Yes. Yeah. After the deliverables, it should be the limits and exclusion. Yeah.
Yeah.
Okay. Any more?
I still want to show my chapter 2 and chapter 3 for a while.
Yeah, sure.
Chapter 2, what I want to ask is on, wait a second. Share contain or word. Hey, how come it's not working? Oh, shit. Doctor, I believe I need to leave for a while to refresh my screen.
It's okay. Okay, you fix your problem first. I received a lot of questions from many leaders. I know I got really sorry for not able to reply and answer your question. That's why I plan to have answering session now. So next, anyone want to ask now that I have not replied to your question? You just show your things and I'll comment.
Doctor, can I ask, is there any way for us to know how many people has responded for our WhatsApp assessment?
Okay. This one question I received many project leaders asking me yesterday since after I sent out the link. So you know that you are using Vivian's system, right? So Vivian will be the one who knows who are the people, let's say from which faculty and department the respondent collected, in and saved in her database. She will save all the data in an Excel file. So I replied to some of the students who asked me this question. So in order to know, let's say your team, my question is not, I mentioned, even I raised this issue during one of the lectures, saying that when you invite people to participate in your HOTS assessment, it is better through your friend, because through your friend, then you get a better response. If you just send out just a very general email, I think it's difficult for you to get response. So if you got friends, you ask the friends to help you, then you get better response. But the question now you ask me is, how do I know? I already collected 120 sets since I do not know what already stored in the database. So the only way I reply to some of the leaders who ask me this question is by contacting Vivian. You ask Vivian to check for you from this faculty, this department, how many students responded, because you can search from the Excel file and then you can sort and then count how many records. That's one way. Another way is I can tell Vivian that at the end of every week, send all the leaders all the Excel file, and then you yourself go and search. You yourself go and search under the Excel file, which are the student is from the department or faculty that they are belongs to your respondent. Then you go and search and retrieve those data. Then you will know how many you have collected. Let's say end of every week, we will just send all the Excel file to all the leaders. Leader go and retrieve the respondents that related to you. Then you can count how many you have collected. So is that okay?
Doctor, does that mean that we cannot access the respondents' data? So it's like we have to get the Excel file from Vivian and then we have to extract ourselves.
Yes, but actually you cannot get from Vivian first. There's another step I need to do because I will be the administrator. Because remember the HOTS assessment question, there are some questions which are subjective. You see, the subjective question, the system cannot do the rating, cannot assign the score. For example, there's a question, give you the diagram and then ask you what kind of, how you interpret this, this diagram is what is it looks like to you, and then you write down your answers within 2 minutes. Within 2 minutes, and then that is called subjective question where you write down the answer yourself. So there's no answer that in the system itself can compare and then whether match and then assign the score. So that kind of answer, it varies from one respondent to another, and I will be the admin to go in, and then after the student submitted this assessment form, this HOTS answer all the questions submitted, then I have to go in and see, there are one student responded or 2, 3, there are many students will be coming in. I will go, the system will tell me that these are the questions you have to go and assign score based on the answer given by the respondent. So after I finish that, then only the complete score will be given and then calculated using the system. And the student later can go in and view the score, view the result. So after you have all in, then only can retrieve the Excel file. Otherwise, then you cannot get all the score of the final HOTS assessment. You understand? So that means there's one more step. Before you can have the Excel file, the admin has to go and assign score to those subjective questions first. And the respondent can only, after that, only can see the final score. Okay now?
Okay, doctor.
Yeah, so that means it's quite complicated. It's not that easy, this project here. Not like others, the C-test, the COVID-19, the survey, and the game, where you just design Google form and then respondent just respond, and then you can check your own database, how many you recorded, how many you collected, and so on, which is very easy. Other 3 groups project actually is considered easier than the tutorial group 3 students, your project. You understand now? So your one is a bit complicated because you are dependent on Vivian's system. And the system got a lot of limitations, and constraint. And we have to, because she designed her business flow in that way that, of course, she cannot, the system cannot be that smart, right? If that is subjective question, there's no model answer that keep track of all the possible answers given by the respondent. In this case, the admin has to do the assigning of the score for that kind of particular type of subjective questions. Okay, now, because it makes sense, right? Logically, no system can be so smart. Anyone, it's just like this Dr. Hairo's test. The last part 3 question is subjective, right? So you have to answer 4 questions for that part. And then whatever answer you give, he has to mark himself. There's no system that can check automatically. But if let's say the MCQ part A, part B, the answer is A, answer B, you can just match. If your answer is A, you get the score. If answer is B, you don't get the score, you see. But for the subjective question, the part 3 one, Dr. Hairo himself has to read and then assign marks. So this is the same case here in the HOTS assessment for the type of subjective question where admin has to go in and then assign the marks. You get the point now?
Okay, doctor. Doctor, I have a question. If we have 120 sets, how many sets do we have to submit?
Yeah, so that means it is quite complicated. It's not that easy, this project here. Not like others, the C-test, the last part 3 question is subjective, right? So you have to answer 4 questions for that part. And then whatever answer you give, he has to mark himself. There's no system that can check automatically. But if let's say the MCQ part A, part B, the answer is A, answer B, you can just match. If your answer is A, you don't get the score. If answer is B, you get the score. You see. But for the subjective question, the part 3 one, Dr. Hairo himself has to read and then assign marks. So this is the same case here in the HOTS assessment for the type of subjective question where admin has to go in and then assign the marks. You get the point now?
Doctor, for second presentation, if tutorial group 3 are unable to come up with the statistics and the outcomes, so how do we present the content?
You will be able to get some data, definitely. So you may not be able to meet 120 sets, but I believe you're able to collect some data. If your team is very good, you got a lot of good friends with you, and then they say your friends that helping you are very cooperative. Your friends that helping you very cooperative. Let's say he or she, you approach one or two. Let's say you're collecting the data from a faculty of engineering, mechanical department. So you got a friend from there. You just ask your friend, please help me. Because now of this COVID-19, our project is just online, you see, and then we cannot go out and reach out to the respondents ourselves because of this COVID-19, no contact, right? So please help us. And then maybe in future, if you need my help, I also can help you. You just talk like that to your friend. Then you're helping each other. And one day, if you need to collect some data, I also help you. You see, I just return your favor that you do for me. And then one day you need my help, I will help you. You see, you understand now? And you from your friend that his friend, definitely, if let's say mechanical engineering, his class there got, let's say, got 100 students. So he tried to distribute, because he of course, you know, at least some of the friends, 30 over or 40, 50, at least 50%. Then ask him to distribute all the HOTS assessment question, particularly to that group of students, but not to all the faculty of engineering students, because you only want from mechanical, but not from civil, not from chemical. So you ask your friend to help in that way, say, please help us by doing this. And then in future, if you need to conduct any study or any research, I will help you in return, you see, for what you have done for me. Then you can collect better and faster, you see, and you can reach the 120 target. I believe by doing so is better. But if you send out a general email to all the students, I think everyone will just ignore you, because they do not know you. They just don't bother by your email. And I believe everyone is so busy because of this COVID-19. I'm sure you realize that because of this problem, this virus here make our life a bit more complicated. Instead of we spend very short time doing certain job, it takes us longer time. It's just like my teaching. I find it, I have spent a lot of time in my preparation, a lot of things, even my supervision of students, it takes much more longer. That's why it's quite stressed for us, and also the student also find it quite stressed, because we cannot have face-to-face, and then we cannot in front of her draw and explain the things that they want to know. And it ended up with a lot of to and fro, you know. It wasted a lot of time. You understand? Okay. So if you can have friends, good friends, you go through friends, you will be able to achieve 120 a set of your HOTS assessment target if you have very good friends around you. You see, there's one team, I think one team leader, I cannot remember from which team, doing the C-test, informed me that they started 3 weeks ago. It's almost 25 days already. They started the survey on the C-test. I don't know, he or she mentioned to me that they only collected 60 sets until today. You see, it's already 25 days. It's almost 1 month gone. But they only collected 60, that means 50% only. So you not yet started, you just started, let's say you started 1 or 2 days ago. Okay, and now if you have good friends, maybe you can achieve even faster than 60 sets. 1 week later, if you have good friends to help you, you may get 70, 80. You never know, you see or not? That depends on how good your relationship with your friends. Okay, any other question?
Doctor, for the chapter 2 and the reliability thing, we are not sure how to calculate the percentage.
You're from what, PG3?
Yes.
Can you please show me your data first?
So, Doctor, we have like the table filled by all the members, but we don't know how to proceed to calculate the percentages.
Okay, under critical thinking, we got 3 questions. So your question number, okay, 1, 2, why critical thinking? Critical thinking got 3 questions, right? One question, 1, 2 only, where is, 3 is the following one, is it? The next number, is it? Okay. Then after is creativity, 1, 2, 3. Okay, good. Okay. That's okay. Okay. You label that is correct way. I think other team leaders, please take note of this when I explain to his question here, and you can follow. Okay, next, after that, you see, after follow the question number under each critical thinking, creativity, and meta connection, then you have analysis, and you see, you got the different category here under logic. Okay, good. and then you calculate what is that number 2, 3. This let's say critical thinking question number 1. You got 2, 2, 2. What is that? 2, 2, 2, 3, 1. This is total marks. So that means this one comes from what? It's a student's score. Is it assigned by one student?
Yes.
Okay. So it'll be very complicated, right?
Yeah.
So you let's say from your own team members, you will have 12 sets of this kind of answer, right?
Yes.
Okay. So one way you can do the analysis is, okay, you keep this, okay, for my reference, that who assigned under which category, that under question 1 is assigned score to which part, okay? Actually, not necessary to have a score for must spread out the 10 marks throughout all this, you know. Sometimes you feel that that question does not have this component, you need to assign. Let's say the question 1, I don't think there's creative thinking, so you just put 0 mark. You just give them. You can even put, let's say I put 5 marks. Question 1 I think got analysis and evaluation, I put 5 marks. And then I think got logic and reason, I got 5 marks. Then the rest I just put 0, 0, 0. You can do like that. So it does not mean that the 10 marks must spread distribute throughout all the 1, 2, 3, 4 the 5 items here. Not necessary. Okay. But anyway, I don't know whether you misunderstood my point or what. It doesn't matter. So now you collected let's say your team got 12 of them. So got 12 sets of these. Now, what you can do is difficult if you go and combine the marks of each part here. You just leave all the 12 sets. Now, what you need to do is you compile by looking at, let's say, your team member number 1. Question number 1, critical thinking. The person assigned marks for analysis and evaluation, you put 1. That means that one student put assigned marks for this component, for this item here. Logic, reasoning, okay, 1 student. Judgment, 1 student. That is the first student answer. This person got all got, okay, all score for spread out all the 5 things here. Then you just put 1, 1, 1. Then you look at the second student. Second student put any marks for analysis and evaluation. Is that none? That means that number remains 1. Then the second student, let's say, put only logic and reasoning 5 marks, and then judgment 5 marks. Then the rest all 0. So in this case, you put the analysis evaluation is 1, but logic reasoning is 2. Then judgment is 2, and the rest is 1, 1. You understand now? That means you compile with all the 12 members. How many go and allocate marks for that particular question, got analysis and evaluation, the number of students who choose that part. Doesn't matter how many scores they assign.
So, Doctor, we're only checking if it's 0 or any other number.
Yes. But you give me the marks that assign also, because from the marks assigned, I also want to know, your team members, they feel that this question is emphasizing on which, because the more marks you allocated for that particular item here, let's say analysis and evaluation, you assign 5 marks, the others you give 1 mark, 2 marks. That means this analysis and evaluation is more higher weightage in this question 1 of critical thinking. You understand?
Yes.
So you leave all the 12 sets of answer there, but you compile how many chosen that one, count by the number of members who assign marks for that particular items.
So, Doctor, we make
then you calculate.
Okay.
Then after that, you can calculate is out of, let's say analysis and evaluation, out of 12 members, they got let's say 7 of them allocated marks for that. So 7 over 12. That means you can calculate that how many % of your team members assign marks for that component. Okay now?
Yes. And Doctor, as a conclusion, should we say like 7 out of 12 members said this question has analysis and evaluation, so we think that this is reliable?
Yeah. So maybe there are some component within the question that no one had chosen. Let's say it is all 0. So let's say question 1, because this case here, this student give all, definitely you don't have a 0 already. So if let's say some other teams, they know how to evaluate in the accordingly, they can see the picture. They say, question 1, I don't think there's any judgment, so I give 0. Another student also 0. They say out of all the 12 students, they assign 0 marks for judgment. That means critical thinking question 1, there's no judgment component there. No that kind of item that I assess from that perspective. So in that case, that question, and then you make a conclusion that for critical thinking question 1, and you found out that for judgment, there's no assessment on that for question 1. You understand?
Yes, Doctor.
So meaning that you focus what is the highest, what is the lowest.
Okay.
But you can also look at the general trends. Then you look at, after you finish all, then you can see whether there's a balance the number of students who assess whether all the critical thinking 3 question, creativity 3 question, metacognition 3 question, have all these 3 total of 9 questions cover all these aspect here. The analysis and evaluation, they all got percentage, and then got logic, reasoning, judgment, problem solving, and then the creative thinking. They are all covered based on these 9 questions. All these aspects all covered in this HOS assessment. That means it is balanced. And then if there's any things that is not balanced, that means there are certain aspects. Let's say, for example, analysis and evaluation is happen in question 1, 2, 3 or critical thinking, very high score in creativity, very high score in metacognition. Then you can make a conclusion, say this HOS assessment, it looks like, based on all the respondents' feedback here, it looks like the emphasis is a lot on analysis and evaluation from perspective of critical thinking also being assessed. Creativity also got this component. Metacognition also got. And then you find out that there are certain aspects, let's say judgment, they got but very low. That means maybe the assessment, this set of assessment question or HOT, not very balanced. That means it's a bit lacking in the judgment and then overemphasizing on analysis and evaluation. You understand?
Yes, doctor.
So now you see, this is to train you analytical skill. You must know how to see the data and then how you interpret the score or the statistics. Okay, other team members, can you understand?
So, doctor, if it's a good HOTS assessment, all these 5 things should be balanced, right?
Yes. If you have let's say the percentage is quite balanced, that means this set of 9 questions covers all these aspects which are needed in HOTS.
Okay.
If they got extreme value, that some very high, some very low, that means that set of questions is not really very balanced. That means that you see, that lead to the question of the bias, the reliability and the validity of this HOTS assessment. You understand now?
Yes, doctor.
So you know what to say in that section of reliability and validity based on this analysis. Okay now? So other team, I hope you understand. Okay, any more?
That's all from me. Thank you, doctor.
Yeah, you're welcome. Okay, next.
Hello, doctor. I'm from tutorial 4. I have a question about the matrix priority of project. If we have a maximum cost, is it a constraint?
Say again. Maximum what?
Maximum cost for the project. Like my group project, we have a constraint for time because we have deadline. And then we want to enhance our performance, which is we want to collect more than 120 respondents.
Yeah.
So is it, but we have maximum cost. So is it constraint on cost, or is it we have to accept the cost because of we want to enhance the performance?
You have to accept the cost because let's say if you just collected 120 cents, this is let's say assuming I make a simple example. Let's say you only need to spend Ringgit Malaysia 100 to collect 120 cents to achieve the objective, right? So, but if you aim to collect, let's say it's instead of 120, you collected double 240 cents. So if you want to collect 240 cents, remember time is money. Definitely you will take more time, right? So if increase time, you will have to pay more and also have to pay the staff to do a more job to collect more data. If you collect 120, let's say you only need 10 days. You collect 240, let's say you need 20 days. So you have to pay salary for the extra another 10 days. So this will be cost incurred. Definitely you're exceeding the amount that you allocated for just collecting 120 cents. So in this case, your cost should be accept if it's exceeding the cost that you allocated. Okay now?
Even though we stated the maximum we need to use.
Yes. Let's say the maximum is you put 100 ringgit, but you collected 240 cents, it end up with, let's say 500, you accept the 500.
Oh, okay. And for the network analysis, if we have more than one critical path, do we need to choose only one critical path, even though we have more than one, we got more than one critical path?
You have to mention all the critical paths.
So it doesn't need to be one only. If we have more than one, we should. Okay.
Yes, not necessarily one. It can be more than one.
All right. And for the last question, for the risk management, can Doctor give an example for micro risk?
Can you show me the risk? Then I can guide you whether you make any mistakes.
my member didn't prepare the risk yet, so she asked about what type of micro risk with respect to our project for the pertaining to playing computer games, like for example of macro risk.
Okay. Macro risk is just at high level overall. What do you think the possible risks that you will happen to your project? The high at the just in the that means generally what is going to happen. Then the micro risk means go into a particular work package. That particular work package, what will happen? For example, let's say the highest level. Let's say I think just now you already mentioned. I think the cost is going to it may over cost, right? Just now you already mentioned if you collect instead of 100 set you collect let's say 120 you collect 240. It's easier. Just now we based on that example. So at the macro level, that is about the cost itself, right? So the cost, it may be over cost, and that's why you have to accept it if it is over cost. So in this case, just now you mentioned, for example, you put the cost as 100 ringgit. So, but the actual one you ending with, if you after monitor, because you increase the number of 120 to become 240, the ending actual cost when you monitor is end up with 500. You see now. So what is this 500? It means, so if you compare 500 with 100, that is a risk here, meaning that you underestimated the cost. So the risk event here is your cost estimation is inaccurate. You understand now?
Okay.
Okay. So now if you go down to micro level. So this micro level means the risk event that happened to a very particular work package. So for example, that means my cost estimation for collecting the data. So I estimated, maybe I put there is 20 ringgit. So because that one is cost with 500. So maybe this is the part here, very particular, this part here, that make the cost underestimation of collect data. So I put there 20 ringgit. Actually, it should be maybe it's 200 ringgit. You see or not? So that go into the micro part.
Okay, understand.
Okay now? Okay, what else?
Thank you, Doctor. Yes.
Okay, welcome. Okay, yeah.
Doctor, I'm from T3, T6. Can I ask about the score distribution percentage? Can I share my screen to show you?
Yes, sure.
Okay, wait. Can you all see my screen?
Yes.
This is the data that I have get from T3, our group, and T3, T1 from the Google Drive. So we just compile all the data into this table. We have 24 sets of data here because we have 24 members in total. So is it the correct way for us to put in the data like this?
Well, I don't understand. Why the number is so big? What is 4214? What is that?
This means that because we have 24 tables, so we just use the, actually initially it's like this. I show you. So actually like 4 is from the table from one of the member. So we just compile the 24 data from this, and then we get this in total. Can you get me?
I still don't get it. I don't get it because it's very confusing. I don't know how can this number is so big. It means what?
Actually, this is like a single number. This means like this. I show you one of the member.
Yeah,
you show one of the table.
Yes, one because it's very confusing to see such a large number. I don't understand. Okay.
Just give me a minute. Sorry.
Okay. But I saw selling or something to show.
Maybe you can proceed with other member first. I try to find the file out.
Yeah. Okay. Any other team leaders, members got question to ask? Better ask now, then I answer your question instead of waiting for my reply.
Doctor?
Yeah.
For the presentation on this Friday, do we will do it on Teams or our own link?
I mentioned that as a risk management, those team, let's say from your team, you got 5 members going to present. So the 5 members, the leader will come out to introduce first all the team members. Just now, which I answered the William's question. Yeah. So when you record this, you record a video first. Your record follow the sequence. I also created a form, right? I asked you to fill in who will be the first, the second present. So I hope all the leaders have done that because I'm going to print out this evening. And then you prepare a video. Let's say out of this your 12 members, and let's say only 4 presenting. So team leader will come out to talk first. You record your part and then pass to the next person to continue the second presentation, which is the second presenter's part. Then followed by the third. Leader is only come out to introduce, unless you are also the first presenter. Then after introducing all team members, and you mentioned that for this first presentation, I only have 4 members presenting. Then who are these 4? And then next you say I will invite my first presenter, so and so. Unless you are the first presenter, then I am the first presenter. I will start my presentation. You understand? So after then you continue with second presenter, third, fourth, and then fifth, because you are the first to introduce all first. Then second, third, fourth, and fifth will be all the 4 members presenting in sequence. So you record all this, you prepare this video, and then if you are ready, you can send to me first. If you're not ready, you can do it. I prefer it before this Friday. You get it done so that because it's on the day of presentation, it could be network problem. So it's just like the day the test. Some people got network problem that, let's say you cannot access the spectrum and so on. You cannot upload file, or when you're presenting, I cannot hear your voice. It's just like just now when I show the file, PDF file, and then I play the sound. From your side, all of you telling me that I cannot hear the voice, cannot hear the sound, you see or not? So that means there's a possible risk event that the sound, you got sound problem, okay? Or video, or your whatever, the audio or video problem that happened during your presentation. So if you have backup with a proper video with all the presenters with your introduction as the team leader, then if you that part I cannot hear you, I will not like give you 0 mark. I will just based on the video to give you the marks accordingly. You understand? That is my risk management. So on that day, you also present according to the video that you recorded that sequence.
All right. On the Microsoft Teams.
Yes. That means yes. It's just like you are presenting the tutorial answers like that. You understand?
All right.
That's the format. Okay. Any more?
Thank you.
There's one team send me your PowerPoint to check. Actually, I will do it afterwards, and I will send you my feedback about your PowerPoint design. But I have a quick look. It looks quite good. Okay. Any other question?
Doctor, can I show my file now?
Sure. Okay.
Okay, sorry for that.
You show the first one first, your team member, how they give you the answer, and then how you make the compile, and then how you present it become that number. Okay.
Okay, can you all see my screen?
Okay. Now I see all the 1 now. Okay.
Okay, this is the original one from me. So I just assign the scores for each of the section. And then because we have 24 sets of this, so after like this one I assign 4, maybe other members assign 3, 2, or 1. So this means that like this 1 4 is from me, 2 is from other team members, 1 is from other team, and then after that we just compile all 24 data into this.
No, just a minute. Go back to the just on screen. The one that from you one?
This is mine.
Okay, this is from you alone. You see, critical thinking, all the 3 questions. You only assign score, and you feel that certain score, it should be leave 0. There's no such evaluation of that component. Okay, fine. But total will be 10. Okay. So this is you. Okay, so your one, when you translate to just now that the very large number, that one is which one? How you interpret?
Actually, this one you just compile the data like this 4, because this 4 is from me. Like I assign 4 here. So the second team members assign 2 for this.
Okay.
The third assign 1.
Let's say analysis and evaluation is 2, and then logic and reasoning is 1, is something else. Okay. Then how you compile this individual become just
after we get this, Then because you said that if we have score 1 to 10, then we just assign 1. If score 0, we assign 0. So this one is just 1, 1, 1, 1. We just compile like.
But you got how many members? You got 12 only, right?
Yeah, and then because you said last time that we can get data from other teams too, so I just retrieve.
Okay. So that means you collected data from other teams.
Yeah, I collect from 2 teams. One is from mine, one is from T3, T1, because I can just retrieve. I just saw T3, T1 upload theirs and then none from others. So I just get from them.
Okay. Now you show me back just now that table with a lot of numbers one.
This
Just now that I said I don't understand that table. This one now I understand. This is your India. Okay. So now this 111 means is you got 20, because you say you got 24 sets. So the 111 is this one, the first respondent assign this value to this. Second also assign.
Yeah.
Okay. So based on this, you can calculate now. Your total number is 24. So definitely the critical thinking question number 1 got 24. Evaluated the analysis and evaluation. Then logic and reasoning also 24 because it's all 1. Then the judgment is 10. That means it's 23. That's the meaning, right? 23 person
after.
Am I right now?
We have also compiled it like this, like 100% of 24% assign scores for this part.
Wait. Yes. Yeah.
This is correct.
Yeah. You can do this way. Yes. That means you based on how many people say that got that component, and then that is everyone say that question 1 critical thinking they consist of analysis and evaluation is 100% all agree on this. Yeah, you can do this. Yes.
So does it mean that we doesn't need this and this table?
Which table? No, you keep all the tables. You explain. Yes. Now I can understand. Now I can understand. Yeah. Now you just stay on this table. Now you take a look. You see now it's very obvious. Which one is well covered. Analysis and evaluation is 100 for the critical thinking, right? And then activity 90 something, 80 something. Don't stay with just now that table. I just got you to do analysis just on that table. Okay. So you just go down under analysis evaluation for critical thinking question 1, 2, 3, creativity 1, 2, 3, and then meta cognition 1, 2, 3. You see, the minimum score is 75% from creativity, right? For analysis and that means this is well covered, isn't it?
Yes.
So the second one, logic and reasoning, 175 mean that's 56 something, right? 58 something is the lowest, right? Okay. Then we look at the other one. Judgment, you can see minimum is also quite high. Okay. Then problem solving. Okay. One with 58 something. Okay. Creative thinking. Okay. So you know how to analyze now? There's 145 something.
So means we are analyzed from the column, not from the row, is it?
No. It looks at overall picture. At overall picture, you can along across the row, you can say looking at critical thinking scale. You see under critical thinking scale, that means all analysis and evaluation is all 100% say they got this 100% agree. The 3 questions cover all this. The critical thinking 3 questions 1, 2, 3, all the questions has analysis, evaluation, logic, and reasoning is all 100% agree on this. And the one is the lowest. You can also look at this way. You see, the lowest is under creative thinking is they don't emphasize a lot on creative thinking. You see or not? So which means it's reflect correctly. You see or not? Because you are looking at the aspect of critical thinking. So this question 1, 2, 3, they're focusing a lot on analysis, evaluation, logic, reasoning. These are the 2, the main focus. You can see a lot 100 there. The creative thinking is the lowest, you can see, very obvious. So you can make conclusion that the question asked, they're really focusing correctly on the critical thinking because it's not focusing on creative thinking. They have the component, but very little.
Okay.
Question they're focusing correctly. Critical thinking that's why you see, if you go and do the literature review, under critical thinking, what are the things that you should have? Analysis and evaluation, logic and reasoning. So that means the are well asked, is correctly asked, and it should not be looking at creative thinking because we are component on creativity. So you look at creativity now, is it creative creativity itself under creative thinking, is it got the highest score? 95.8300.
Yes.
So that means the question asking under the creativity part is also is correctly questioned, because that creative thinking part must have the highest score. So you compare,
Okay.
it's true. You see, it's true. That means the question was asked is correctly asked for creativity. Okay, and then meta condition. Understand? Meta condition is focusing on what? So it should have which other components should have the highest score. Then you analyze that way also can. Okay.
Okay. Then do we have to show this too? This is the total for the scores from 24 sets of members data.
You keep all the data for the every single one, and then you explain how from one data you compile to that 24, 111, the 0, and so on, and then how you calculate this percentage.
Okay,
and then
so
you make conclusion, say this set of 3 questions from critical thinking, creativity, and meta condition, is it have achieved the reliability and validity?
This like the data analyzing part is under this table, is it?
This one, no, just not that percent. This is the total number, is it?
This is for the percentage, and then this is for the total marks.
Oh, okay. This one is total marks. Okay, can see which one is the marks allocation by all the 24 team members.
I mean, where should we put the data analysis part, or we just? We just.
You have to explain. That means you show this table, and then before this table, you write the explanation. So you say as shown. Let's say this table 3. This chapter 2. Let's say this table 2.5. Okay, as shown in table 2.5, it shows that like just now the percentage. Critical thinking, under critical thinking, all the 3 questions from critical thinking skills, question 1, 2, 3, they all achieve 100% of analysis and evaluation. So that means this reflect that. That means for critical thinking, this component is the main focus. You see, which one that and because you also mentioned that based on literature review, analysis and evaluation, logic and reasoning is part of critical thinking that you must have.
Okay.
So, and based on this respondent, the feedback on this is also show that they also mentioned that they are all 100% for both achieved. So this reflects that the question asked in question 1, 2, 3 of the critical thinking has really covered this. That means the question have been asked correctly to evaluate the critical thinking and cover analysis and evaluation, logic and reasoning.
Okay.
Because of 100%, what? If let's say if critical thinking does not, the focus is not on the analysis, evaluation, and logic and reasoning, is something else. But then these 2 score 100. Then you mentioned that the question is not asked accordingly. That means there's invalidity of this question asked. It's not asking the right thing. You see or not? That means the focus critical thinking is what? And if that is the one must have, is it everybody agree that this question already assessed on this part? No need to be very complicated. You just focus on critical thinking must have what, and then all the respondents say, they all say that if this question also consists this, then that means our set of question is correctly, or the question was asked not in a correct way. That's the main focus: reliability and validity. Okay now?
Okay, understood.
Okay.
Can I ask for one simple question more about the macro estimation and micro? Sure. Because you did mention that we need to compare between these 2 approaches, and then is it okay if I compare like this?
Yeah, can you please show me the macro and the micro? What is the value for macro and what's the value for micro? Micro will be using work packages detail, right?
Yeah.
Macro is which approach? Is it a portion or what?
For macro, we are using a portion method, and we assign 10,000 for for macro.
So that means you straight away assign one a lump sum. That's it. That's according. That means your rough estimation. So using your WP, what's the total now?
Using WP, we get 1,363.
I think it cannot be, because let's say in data collection, how many of your team members involved in this data collection? So you have to assign salary, Remember there's a labor cost.
Yeah.
So your labor cost very cheap.
Means we are underestimate, is it?
That's why if you compare your macro and your micro, it's a very big difference. 10,000 and 1,000 something. That is a big difference. That means you're underestimated using the WP. The salary cannot be that cheap one. It's just like now programmer, IT staff, they are very well paid, you know. So you underestimated using the WP approach. By right, WP should be more accurate than the macro. The micro one should be very detailed, but because you're inexperienced, that's why you say you can come to your risk event. You are underestimated using the micro approach because you are inexperienced in cost estimation. So you allocated the cost incorrectly. So in the end, your project will be resulting in over cost. Because if you're using micro approach, you're only 1,000 something. But at the end of the project, it may end up, let's say, 12,000. So your project is over cost because of the risk that you are not able to estimate the cost correctly.
So that means later after I change this, I also need to put the under overestimation under the risk management, is it?
Yes, you're underestimate. Yes. That means your risk event is due to inexperience in cost estimation, you underestimated the cost. And because you underestimated the cost, then the consequence is your project end up with over cost. Now you can see the whole thing how related to this.
But eventually I also have to change this, right?
So that comes the change management. You see, some students ask me what is change management. So you estimated this. After that, you realize the risk event will happen. So you make a change now. You go and re-estimate. So your change management come in.
Okay.
See the full picture.
Understood.
You see? So other teams are asking me what is change management. So you can base on this TG3, T6 experience, you see the whole event. The risk event happened already. And now you make a change because you are underestimate now. But it's not too late yet. You're just halfway through. You realize it was underestimation. Then you go and make a change and re-estimate. So there's a change you make in the cost estimation.
Okay.
So the committee in charge of this change management approve, and then you go and update the cost of 1,000 something become 12,000 something. You understand? Then you're safe. Okay now.
Like for this last question. For this is it by comparing between these two approaches, we notice that we have overestimated our project cost with the difference. Later I will change this by using apportion method. So is it the correct way for me to come up with this conclusion?
Yeah, because you feel that you overestimate. You thought that the macro approach is not so accurate. The micro is accurate. You underestimated using the WP approaches. It's the reverse. Actually, you underestimated, not overestimated in the micro approach. You see,
Okay. Okay. That's it.
Yeah. Understand now?
Thank you.
I say. Why you really understand? Yeah. Yes. Who wants to ask?
Good day, Doctor.
Yeah.
I'm Bujisang from TG2, T6. I'm going to ask about. Now I have 120 respondents.
Oh, good. You achieved target. Good.
300 achieved the main our target already, but now the problem is some of the department have no only 10 plus people only. Is it can accept?
No, I want to know. Okay, this some department only 10. There are many departments under one faculty.
Yeah, because I chose four department from faculty science and 2 departments from faculty FBA.
Yeah, okay. So the total of these 4 faculty from science and the 2 from the FBA, they are total up. They are more than 30, right?
Yeah.
Then you are safe. Okay. So you just analyze according to faculty instead of department.
Okay. Total, I got a question about the work package for my micro cost estimation.
Okay. Show me.
Yeah. Instead of can we try for for the duration, like we need to write in week or just can we state like 7 day work like that?
Can. You can say let's say the work week is 7 days. My work week is 5 days. You have to define in your description that you have to define that in your project report. Let's say the week 1 it means it's the 5 working days. The 1 it means 7 working days. You just explain that.
Okay. So for example, for my work package for one, I have like 9 days. So how I need to write in the work period?
The WP got 9 days. Then you spread into the second week. Let's say you got 7 days. You got 7 days, right? Then you have to take it consider as 2 weeks.
Okay. So for example, 9 days. Then for my course, then I separate to 2 weeks. Then the first week will be the 7 days, and the following one is the left one.
Yeah, a little bit lah.
Okay. Understand. Then wait, madam, I'm doing. I'm showing I show my page first because I want to madam to review my network.
Yes, okay, sure. Your network one, is it same unit of measurement? Is it also work days or work week?
For network we use days.
Okay. It's more precise.
Like this is our network diagram. Network analysis diagram.
Can enlarge.
I think this one will be the larger.
Your labeling of this diagram, use figure instead of using the word diagram. Figure.
Okay. So then does this figure that I want to put in appendix or here?
You only have one, right? One diagram only, right, for network diagram?
Yeah.
Then you put in the main chapter. If you, let's say, the estimation, the WP got many sheets, right? Let's say 20 pages each. You got 20 WPs. So one WP is one sheet. So you don't have to put all the 20 in the main content of the chapter. You just put 2 or 3 samples of the WPs in the main chapter, and you say the others are put under appendix, let's say appendix C, something like that.
Okay.
For this one, you put about 2-3 sheets and illustrate with these 2-3, explain these 2-3 pages of these WPs only, and then you say all together they are 12, let's say, or 24. Okay, I don't know how many you have. Okay, and then the remaining here in this chapter here we show the 3 of these. Then the remaining of these WPs are included in this appendix C, something like that. Okay.
Okay. Madam, for this total for this duration for example, I have 2 work week so I need to write 14 days work week, 14 days work, or just 2 work weeks.
Your representing is your 1, 2, 3, 4, 5 is work weeks, right? So you put there work weeks.
So we must be like constant for each. For example, I write all in work days, so I write 1 in all weeks, so all days work days. So others one I also need to write work days instead of work week.
Because now you have to standardize in your WP. Okay, let's say your work days, 7 work days, is it equivalent to 1 work week? That means 1 week you work for how many days? Is it 5 days or 7 days?
Friday, I think.
Okay. So that means it's 1 work week is 5 days, but here you put 7 work days. Then you have to drag on until the second work week, because if 1 work week is 5 days, this one in this sheet here you got 7 work days. That means you got 7 days. But your 1 week is if you this 1, 2, 3, 4, 5 represent your this 1, 2, 3, 4, 5 is work period is what is that's why is it work days or work week? But in this case I can see it's 7. It's work days.
So I need to standardize all.
If you all work days, then leave it all work days If you all work weeks, then it's all work weeks If you're already done in all work days, and you leave it Otherwise, a lot of changes to make.
Madam, for example, like I write 7 work day, right? Can I write like the work period in week, like 1, 2, 3, 4, 5?
But here, but you see, you up there put 7 work days, and here 1, 2, 3, 4, 5, 6, 7. I will assume this is work days
Okay. So that this is okay because got some like the WP is for like for example like 2 work week, so we have like 10 days like that. So I need to write here is week or
No,
days.
you have to convert. Let's say you got all our work days, then suddenly you got one sheet is work week, and the work week is actually is taking 10 work days. Then you convert to these work days because so that is standardized.
So here must be 10 column.
You see, that's right. Remember up there you got page what of what. That is you're going to carry 2 pages. So your first page 1, 2, 3, 4, 5. Next page is 6, 7, 8, 9, 10. So you got page 1 of 2, page 2 of 2 now. You understand now?
Okay.
Okay.
Understand. Okay. I think nothing more to ask.
That's why any part that you don't understand, you just ask me now, then I can answer very fast. So you don't have to wait in the queue. See? So I type a lot. It's taking a long time. Yes. From
I'm from TG4 T4 from Woyong Group, and then we have something to ask for. Let me share my screen, can?
Yeah, sure.
Can you see this?
Not yet. Okay now. Can you make
this? Yeah, this is the PBS from our group, and then I want to ask that for our PBS, is that acceptable for us to implement in this form?
Can you enlarge it a bit? It's very tiny. Can't